Welcome back to this course on blockchain and its applications. So, in the last class we have mentioned that there are multiple different applications or there can be innovative idea on blockchain apart from these financial transactions or logging the financial transactions over a DLT or distributed ledger technology. So, today we are going to have a journey on that and we are going to see that how you can use these DLTs in an innovative way. So, we are going to talk about something called smart contracts and then the enterprise blockchain architecture, which is called the permission model of blockchain. So, the concepts that we are going to cover today are smart contracts and the automated code execution on top of smart contracts, and then the idea of permission blockchain. So, these are the keywords smart contract. So, in the last class we have looked into blockchain 1.0, which is the distributed ledger technology, and today we are going to see about blockchain 2.0 and blockchain 3.0. We are going to have a discussion on the permission models of blockchain and the enterprise blockchains. So, this is the point we are discussing in the last lecture, that in DLT you can keep other information apart from the financial transaction. So, what I was mentioning, that submitting an executable code as a transaction within the DLT. So, in that case, if your transaction get executed, that basically means your code is getting executed. And because it is a distributed architecture where you are running a consensus mechanism, that means you can get a consensus on the state of the code that is getting executed, and that actually gives immense power for developing applications which are truly decentralized. So, we are going to see that today. And this entire idea, that means running code or running executables on top of a distributed architecture like blockchain, that actually gives or raises the idea of something called a smart contract. So, the idea of the smart contract says that you automatically execute a code or a contract over a decentralized platform. If you just try to see that the traditional way of maintaining the digital contracts, so in case of traditional way, what we typically do, that the contract that we have, this particular contract, first say two persons they agree on a contract, and then you submit that contract to some centralized platform like a cloud platform. Now, once you are submitting this content in a centralized platform like a cloud platform, then the contract get executed over the cloud, and individual person they can submit their input. So, say the certain state of the contract get executed and the replies are sent back to the participants. Similarly, the second participant can submit a input to the cloud, and again the responses are coming from the cloud. So, that means you are using a centralized architecture to execute the contract, and whenever you are using a centralized architecture to execute the contract, different persons they independently are going to submit their input, and the contract is getting executed over cloud and sending you back the response. But with this kind of centralized architecture of contract execution, that whenever you have multiple people who collectively execute something or who collectively execute certain contracts among themselves, so having a centralized platform has certain issues. So, what are they? So, the first issue is that how will you check that the inputs are valid? Because I am going to submit the input to the cloud, and you cannot really see that what that input is. Even if you are being able to see the input, how will you know or how will you claim that, hey, this is the input that have been submitted by me? It might always happen that later on I deny that I have not submitted that input, some other person have just impersonated me and that person has submitted the input. So, in this particular case, this becomes challenging, that means writing a contract or executing a contract over a centralized platform. So, it becomes easier, as we will see, that to execute the contract in a complete decentralized architecture. Now, how does it work? It works like this. Say, assume you have certain decentralized code, certain contract. What are this contract? So, here is a kind of simple piece of code. Let me explain it. So, what this code is doing? You have a function called pay. So, this function takes one sender account, one receiver account, and one amount value. Okay. Now, what you are doing? You are checking that whether the sender account is less than amount. If it is less than amount, the amount that you have to pay. So, if you have less money compared to what you have to pay, it returns a -1, indicating that it is a failure. Otherwise, what it does? It deducts the amount from the sender account and adds up that amount in the receiver amount and returns a 1, indicating a success. So, this is something like a payment function. Well, so I am mentioning that how much money that I want to pay. So, this is represented by the amount, and then it checks whether the sender account has that much of money. If the sender account has that much of money, it makes that payment, that means deduct the money from the sender account and makes a payment to the receiver account and then returns a success. Then I have another function called deliver goods. So, what this function is doing? This function is taking the count, that means the number of items that I want to deliver, and price per C, that is the price per count. Well, so what is the price per unique item, individual item? So, what it does? It first make a call to this payment function. So, it checks that whether the payment is successful or not. If the payment is successful, then you schedule the logistic, make a call to another function called schedule logistics, that actually initiate the transfer of the items from the sender to the receiver. Well, and then you are returning an 1. Otherwise, if your payment was not successful, you are returning a 0. So, broadly what these two function is doing together, it is something like that. I have a sender and or I have say or let us use the term sender and receiver. I have a sender and I have a receiver. Well, so what the sender is doing? The sender is putting up certain order. So, when the sender is putting up certain order for the receiver, so this sender is say the buyer, sender in terms of sending the money, receiver is the seller. Well, so the sender or the buyer is putting up the requirement, well, and then it checks whether there is sufficient money. If it is there, it make a payment for that money, and after the payment is successful, it initiates the delivery of the good from the seller to the buyer. Well, so this is the kind of a simplistic flow which is happening here, and this entire simplistic flow I have tried to represent in the form of a code, well, a form of an executable code. Now, let us see that how we can actually execute this code in reality. Now, whenever you are executing a code, I guess that all of you know that any algorithm or any executable piece of code can be represented in the form of a state machine. So, what is a state machine? Say if the code gets partially executed, I basically maintain a state of that execution, and then in the next time I start from that state of execution. Well, so what does it mean? That means that say this is my initial state, that the sender account has amount I, the receiver account has amount j, and the count is equal to 0. So, that way I am initializing the state. Now, after that, say I make a call to this function deliver goods 10 4, that means I am going to transfer. So, my count is equal to 10 and price per C is equal to 4, that means I am going to send 10 items and price per item is 4 rupees or 4 bucks. Well, so my state gets changed to this pay function gets called. Whenever this pay function is getting called, it is returning more than 1. So, assuming that I is more than 40, if I is more than 40, then the sender account becomes I minus 40, the receiver account becomes j plus 40, and the count that becomes 40. Well, so that way I am just making a kind of transition from one state to another state while I am executing the code. Now, how I can design a decentralized model of execution for that code? What I can do is that I can put the states of execution for this code in a blockchain. So, that way what will happen? That whenever the code is getting executed, during that time you are maintaining the state of execution. So, that way if the code gets partially executed, everyone in the blockchain knows that how much of the code got executed and what is the next point from where the execution actually starts. Well, so this helps me to run the code in a complete decentralized way. And how it is helping me? It is helping me by answering the question that I made while discussing about the contract execution in a centralized architecture. So, in a centralized architecture, your problem is that you really do not know how the execution is actually happening, what are the inputs which are coming from different people. So, whatever that centralized architecture, that means your cloud storage is returning to you, you have to rely on that information. That means you need to always rely on the state of the cloud. Well, and the cloud is always something which is being provided by the third party. Well, so that means there is always a possibility that well, certain attacker may raise an attack on your cloud based system or a central system where the computation is going on and can make certain changes in the computation. Well, so in a decentralized architecture you can prevent that. And how you are going to prevent that? You are going to prevent that by maintaining the state of execution on the block on the blockchain and then monitoring the evolution of the blockchain on the execution of this code. Well, so this kind of automated execution of the code, it is termed as the smart contract. So, let us see that how this smart contract execution happens. So, in my earlier example, so they prepare an offline contract. When the contract is prepared, now rather than submitting the contract in the central server, central cloud server, you submit the contract in a blockchain. Well, and you can also submit a kind of anonymized version of the contract. That means you can use public key encryption. So, later on we will see in details that how you can use public key encryption to submit the contract in the blockchain. Once you are submitting the contract in the blockchain network, then actually the other persons who are there in your blockchain network, they can monitor the state of execution of this contract and they can verify whether the contract have been executed successfully or not. Well, and later on we will see that how you can write a smart contract. We are having certain tutorial as a part of this course which will explain that how to write this contract, how to monitor the execution of this contract and so on in the context of Ethereum distributed applications or DApps, and at the same time we will see another blockchain platform called Hyperledger Fabric. We will learn all this in details, but here the broad idea is that you can have a kind of complete decentralized model of executing the information. So, that way I would just suggest all of you to look into one popular game which was developed on Ethereum. So, this game is called CryptoKitties. So, let me just play a video which actually shows a demo video of this CryptoKitties. So, this CryptoKitties is actually a game where you can buy kitties or cats, and then you can dress the cat just like you do. You can make your cat play with the cats of your friends, well, and then you can sell cat, you can buy cat, and that way you can do a lot of stuff with these cats. Well, and the interesting fact here is that this entire game, it is hosted on a decentralized platform. That means, we do not have a typical gaming server where this game is getting executed. Rather, the game gets executed in a kind of complete decentralized architecture, in a complete decentralized platform, and that way you do not have a central gaming server where you are maintaining the state of the cats. Well, rather the state of the cats are basically maintained in the form of a in the form of a blockchain and in the form of a smart contract. Well, so I would suggest all of you to download this game. This is publicly available, and try this game. At least you can get a flavor about what decentralized app means and how it is a kind of gives you a kind of seamless experience without getting connected to any centralized gaming server. So, this is a kind of practical example of having, or a kind of utilization of blockchain which is beyond cryptocurrencies. Now, if I just try to move further, that the execution of the smart contract on top of blockchain, this particular thing was termed as the blockchain 2.0, and at this point of time people started thinking of that if I can apply blockchain in other applications as well. Well, where or kind of many industrial or the commercial application or the enterprise applications as well. So, you remember that on the first lecture I talked about this supply chain management, which is one of the prominent application of blockchain, which is a kind of enterprise application. You have a set of distributors, you have a set of retailers. So, we discussed about in the context of petroleum industry, where we have the refineries, the distributor, the retailer, and so on. And in that particular marketplace, we have seen that, well, if I can lock every transactions in a blockchain, that can bring transparency in the system, and that can help in having a better management of the entire end-to-end supply chain. Now, let us try to think of at this point that if I want to apply blockchain in such kind of architecture, and if I think of a open consensus mechanism such as proof of work or the Nakamoto consensus. So, what we have seen earlier, that this Nakamoto consensus, it works good in an open network. Now, when the Nakamoto consensus works good in an open network, the major problem with this Nakamoto consensus is that the transaction latency is very high, because the miners, if you remember, they have to solve a challenge, and solving that challenge is not very straightforward. The miner need to do a kind of random search to find out the nonce compared to the target hash that we have, and in that entire process they have to spend a significant amount of time. Now, typically if you just try to look into the Bitcoin block commitment protocol, there you will see that this Bitcoin roughly takes around 10 minutes to commit every block. Well, so it is really very slow. Now, in case of Ethereum blockchain, it is something like few seconds to few minutes, depending on the cost that you pay. Well, so Ethereum has a different model of execution, and based on that model of execution, it takes from few seconds to few minutes. So, that way this transaction latency is very high and the transaction throughput is very low. Because the latency is high and the throughput is low, you really cannot apply such kind of applications in a realistic environment, or rather realistic environment in the context of the enterprise applications like supply chain management. Well, say in case of my financial transaction, that is still good, because you have initiated a transactions, and after a few minutes, say after 10 minutes or so, the transaction is getting committed. So you can well, later on we will see that you will not be able to immediately claim the money, you need to wait for some amount of time, but still you can tolerate that. But in a supply chain management, this entire thing need to be done in real time. So, the moment certain information has happened, you need to immediately log it. If it gets delayed for few minutes to few hours, then what might happen that by that delay certain fraud might occur. Well, so that way these enterprise applications, what they demand that well, the transaction throughput need to be very high and the latency need to be very low. So, the question comes here that how we are going to ensure this? Well, so from here the open question that comes, that can we think of the blockchain applications which are beyond cryptocurrency and which needs such kind of enterprise grade requirement? Well, because this high latency which is there, it makes the blockchain unsuitable for most of the real time applications. So, you cannot apply blockchain in any of the real time application because of this high transaction latency which is there. So, from here this permission model of blockchain that got evolved, and the major observation here is that many decentralized application, they do not demand an open environment just like the cryptocurrency. So, one of the major requirement behind cryptocurrency was that it demand an open environment. So, you need an open environment where anyone can join and anyone can participate in a financial transactions. Well, but for many of these enterprise grade applications, we do not need such kind of open environment. So, for example, the food supply chain. In food supply chain, you know that these are the players. Well, it is not like that there are infinite number of players, infinite number of distributors or suppliers or something like that. So, the distributor or suppliers, they majority of the time they form consortium among themselves, and within that consortium they keep on making the transactions among themselves. Well, then there are other factors like the know your customers or KYC. So, in case of KYC, say again say you are validating your identity. So, the agencies which actually validate the identity, they are again very limited. Well, maybe whenever you are going to a foreign country, during that time at the immigration checkpoint your identity will be verified. Well, or whenever you are opening up a bank account, your identity would be verified. So, there are certain specific applications where the identity would be verified. Then trade financing. Well, so the banks, they basically support this trade financing, or for doing the trade financing you need a kind of network among the banks. Again, it is a kind of limited entity, although it can be large. There are many banks, there can be many banks, but the number of banks are limited. So, that way many such decentralized applications, they do not demand an open network, and the number of participants in those network are limited. Now, when number of participants in a network is limited, during that time people started thinking of from the scratch that well, we have a data structure like hash chain, where I am connecting every block via the hash by using the hash of the previous block, and that way I can generate a tamper proof data structure. But at the end what I need, or at the back end what I need? At the back end I need a consensus mechanism which will ensure that well, a block has came through a particular consensus among its participants. Well, and in an open network we had seen that well, we cannot use the classical distributed consensus mechanism. So, that is why they have thought of that well, the classical distributed consensus mechanism which gives more priority to safety over liveness. Let us just think of in a different direction, that let us try to give more priority over liveness, which is again much more suitable for the financial use cases, that your transactions may not be committed immediately. It takes certain time to get commitment, but with that kind of limitations you can design an open consensus mechanism based on that challenge response architecture. But in a permission in such kind of model where the network is not open, you can possibly revisit the classical consensus algorithms, and you can try to see that whether the classical consensus algorithms are suitable for this purpose. Well, so this gives the rise to the idea of blockchain 3.0, which covers an idea called trustless decentralization. So, what trustless decentralization means? So, trustless decentralization means that you have a closed network. Well, in that closed network, you want to automatically transact the assets among multiple organizations. These organizations, they know each other, but they do not trust each other. Well, just like our use case of supply chain management, I have multiple distributors, I have multiple vendors, but everyone is in a business. Now, when everyone is in a business, they are the competitor to each other. So, if I can share information among themselves, they can possibly utilize the supply chain or a market in a better way, but because they are competitor to each other, they do not directly trust the information that is being provided by others. Now, when they do not trust the information that is being provided by others, then the question comes that can we have a trustless architecture that can help me to store those information. So, what I can do that I can run smart contracts within a consortium of various organizations, where the individual organizations, they know each other, but they do not trust each other. Well, so this idea is known as trustless decentralization. So, I want to have a decentralized architecture within a known consortium, well, because I do not trust each of the participants in that consortium, because all of them are competitors, although they have a common business goal. Now, the advantage here is that we can go back to the classical distributed consensus protocols, which are having low latency for commitment and high transaction throughput. Well, so we can apply those consensus algorithms here, and we can design a consensus mechanism out of it. Well, and we can use mechanism like witness co-signing instead of proof of mining. Well, so the proof of mining is the proof from the challenge that we have seen earlier. Rather than that, what we can do, that I can take a signature from digital signature from all those participants, marking that well all of them are collectively agreeing on this block. Well, so that way what I can do, that I can use the classical distributed consensus algorithm along with digital signature and the other cryptographic techniques to generate or to run a blockchain among the set of known participants who have a kind of common business goal, but they do not trust each other. So, this gives the rise to the permission model of blockchain. So, in case of a permission model of blockchain, in contrast to the permissionless model that we discussed earlier in the context of Bitcoin and the open blockchain network, here the participants are pre-authenticated and pre-authorized, but they can still behave maliciously. So, because they are the competitor to each other, so that is why you do not trust them, and we want to run blockchain and smart contracts on top of this closed network. Well, so we want to ensure trusted computing among this participant. So, this is the kind of idea of permission blockchain which becomes very much popular in the enterprises. So, what we see here, that this idea of smart contracts, it revolutionizes this blockchain or the DLT applications. So, you move far beyond compared to the financial applications. So, blockchain is not anymore limited to the financial applications or cryptocurrencies. Rather, you can take help of smart contracts and distributed applications to design different kind of innovative applications or support transparency in existing systems like a supply chain management, and you can do automated code executions over a decentralized platform. Well, so these permission blockchains that they have emerged for such kind of enterprise applications. So, this gives you a kind of a very broad overview about this entire blockchain space, starting from the cryptocurrencies to the idea of distributed consensus, followed by how distributed consensus have been applied in an open network, and then we have seen this rise of smart contracts and permission model of blockchain, and it actually gives you a kind of entire spectra of different kind of techniques which are used within the blockchain architecture. So, in the last 4 lectures that I have taken, I have tried to give a kind of overall summarization of the technology. So, now gradually we are going to start look into the technology in more depth. That means, we are going to look into the internal structure of the blockchain, and then we are going to look into the consensus mechanisms in details, both for the permission model of blockchain as well as the permissionless model for blockchain. So, in the next lecture, Professor Shural is going to talk about this internal structure of a blockchain, and then I will come back with the different kind of consensus mechanism which are being applied over a blockchain. Okay. So, that is all for this lecture. Thank you all for attending. So, as I mentioned that Professor Shural is going to continue from the next lecture, and then again I will come back with the discussion of the different kind of consensus mechanism. Thank you. Take care.